Thanks for coming after lunch. Hope you're quite intrigued by the title of the presentation. I hope so. I'm not going to show you any code today, no live demo. It's going to be more like abstract overview of how I think the future will look for us. It's kind of going to be my prediction. And I'm expecting your questions. We may disagree, we may discuss that. I'll just show you the dynamic I see right now, what's happening and how we're going over the last, I think, 15 years and what I think will happen in the next, I don't know, 5, 10 years. So I tried to look at the time goes from left to right. So I try to analyze what I've seen in my work, working with servers, where web applications are deployed, and I started doing that about like 15 years ago. And the first step was SSH, so it was like terminals, connecting to servers, making changes. We'll discuss it right now. The next kind of phase or era of how servers are managed, I separated into two different directions. The first one I call Chef, and I'll explain now why. The second one I call PaaS, which is a platform as a service. You probably know what it is. And then the step number 3, which happened like over the last 3-4 years, I called it Docker, kind of label it as Docker. That's what I see is happening. And the last one, this is the prediction. This is what I think will happen. I called it immutable servers, IS. It's not just my prediction. You probably read articles about immutable servers and what it is. But I will try to explain how I think we will work with servers in the future and how we will actually keep them in GitHub. So how our servers will actually stay in GitHub and how we're going to modify them. So the whole road is from SSH, from terminals, to GitHub, kind of. So let me start. The first step was SSH. I'm sure you know what it is. How many actually system administrators or people who use terminals are here? Can you raise your hands? Not so many, about like 30%. So the rest are programmers, I guess, right? So you're writing code, but you don't access servers. Am I right? But you definitely know what SSH is. You have to. So this is it's a daemon running on the it's SSH kind of it's a name of a client, but the daemon is called SSH daemon. It's a software which stays on the server and helps us to connect from the client, from my laptop, to connect to the server and make modifications on the servers. So this is how it all started, this web development. So we buy a computer, just a computer, we connect it to internet, we put it in some hosting center, and then we run the Linux there or any other operating system like Unix kind of, and then we start the daemon, which listening on the TCP port and the TCP port 22, and then the clients all over the world, they're able to connect there to the server and make modifications to the software installed there. So system administrators, they were, it was a title, it's a job title of a person who knew how to make modifications to the server, how to install Apache there, how to install PHP into Apache, how to install MySQL, how to make all these modifications and maintain the server. So server starts today and it goes for many, many years, staying there unchangeable. Well, it stays the same, but the person, the system administrator, keeps updating it, keeps making modifications. That's how it all worked. That's how it worked for years. Most web systems were managed, administered like that. There are tons of software created to help the system administrators to administer the server, to see what's going on the server, to regularly log in there and check the status. And there were created a number of tools for that, like package management tools, which allow system administrator to install that products there, like Apache, for example, in one line. So 10 years ago, 15 years ago, when I was installing my first web servers, it was like a work of a full day work or 2 days of work in order to install Apache, to install PHP, MySQL, put it all together and make sure they work together. It was necessary to get the source code of Apache, compile it all, make sure it actually compiles, install C compiler, all this together. So it was like full time for 1 or maybe 2 days of work to install everything. If you have 2 servers, you have to do it twice. So you have 2 servers, you log into the second server, you do it again. You log into the third one, you do it again. You do it manually. And then they introduced this package manager. So you just log into the server and you say apt get install Apache. Enter, it works for like 10 minutes, 15 minutes, and boom, Apache is installed with default configuration. Then you want to just change the configuration, you change some files, and it works the way you want. So it was a great achievement which happened, I don't know, maybe like 10 years or something, maybe even earlier. So that's the first phase. That's what we had. It's gone. Like professional administrators, they're not doing that anymore, to my knowledge. So this is like kind of in the past. What we have now is called, I would call the chaff era. So probably you know what the chaff software is. If you don't, I'll explain in a few words. The chaff software, and there are a few other softwares which are doing the same, like Puppet or Ansible, and there are 20+ tools I just found yesterday Googling them. I know just Puppet and Ansible, I never used others, but the chaff is kind of the main one, I think, on the market. And what it does is that you install it on your main server, this chaff software. It has a web panel, and then you log into this chaff to this panel and say, I have 15 servers or 50 servers, and these are their coordinates, their IP addresses. This, and that one. So you put a list of servers, all the IP addresses, and you configure how this main machine can access them all. And then you say from this main machine, install Apache to all of them, and then the chaff goes to all of them through SSH and run this apt-get install Apache. apt-get install Apache 50 times. That actually saves you a lot of time. So if you're a system administrator, you don't need to go 50 times there. You don't need to install it manually, of course, like it was before. And you don't even need to run this apt-get anymore, because Chaff will do it all for you. So it automates this routine operations. And then, for example, you want to upgrade Apache. It was version number 2.3.9, and then you want to upgrade it to 2.3.10. So all you do is you log into Chaff and say, now I want Apache 2.3.10. And then the Chaff goes to all of these servers and upgrades them automatically. And you can define the so-called cookbooks and recipes inside the Chaff. So you can write in Ruby. This Chaff is Ruby-based software, so you can write like small scripts or small pieces of kind of recipes. And you say, like, I want not just Apache. Apache is the default recipe. So you just download it, it's open source, and it's a script which explains how this Chaff machine gets to the server and what exactly it has to do there. You can create your own recipe and say, I want MongoDB there to be installed. Or I want my own application to be installed. Or I want something else. So you, as a system administrator, you configure all the steps. You put this recipe into Chaff, and then Chaff goes everywhere and runs it again and again. If something goes wrong, for example, on one server it logs in and it breaks, the script cannot run, then Chaff informs you and says, like, server number 15 actually failed because this and that. So it's easier. So professional system administrators, they don't go to servers manually anymore. They create recipes and cookbooks in Chaff. And then they just look at this Chaff machine and configure everything and monitor. If you have thousands of servers, it's like that would be really weird if you still have SSH access everywhere and you contact them like individually and make changes there like individually. You log in there. It's not happening. So it's kind of Chaff era. It's just everywhere. If you're a system administrator, you definitely know what I'm talking about. The OpsWorks, it's the product from Amazon Web Services. So if you're using them, you definitely know what it is, because now many servers, I mean, we don't buy them anymore. We rent them from Amazon or similar platforms like Google Cloud or Rackspace or somebody else. But the Amazon is #1, so when you rent these servers on Amazon, you will need this, you can get this OpsWorks, which is exactly Chaff. So inside this product, there's Chaff there. So all they give you is the ability to do the same inside Amazon environment. So you rent a number of instances in Amazon, like 100 machines, and then you get the account there, and then all of these 100 machines get under control, and you specify the recipes, and they get deployed to machines. So recipes, they deploy these recipes to machines. This is what's kind of fresh. This is state of the art, sort of. At the same time, this is like, I remind you, I jumped back 2 slides. So that was the direction that way. So we forgot about that and we jumped to Chaff. But there's another direction where we also, stepped into, like about 7 years ago or something, which is called platform as a service. So we're kind of forgetting about servers at all. So we don't have this idea of having a server and forget about SSH again, so you don't log in anywhere. But in this case, you don't have a server at all. You don't think in terms of servers. All you think about is your application. Well, I'm writing in Java, so in my case, it's just a jar file. So it's a file packaged as a Java application, and I give it to some platform, and the platform decides where to find the server, how to install Apache there or not Apache, how to configure everything, and then how to run my application. So I don't know about the IP address anymore. I don't have an IP address of the server. In case of Chef, I still work with machines. I still know IP addresses. I still know, I know the logins. I know where physically this machine is located. In this case, I have no idea. All I do is I package my application, I put it to the platform, and then this platform deploys everything and it starts to work. A number of solutions. Heroku is probably one of the most popular, I think, and Elastic Beanstalk is one of the most serious, I think. That's from Amazon. This one is from Red Hat. Am I right? OpenShift, Red Hat, right? Yeah, so OpenShift is from Red Hat. I have no experience with this one. Well, kind of tried. But these two I'm using like in a number of projects. Heroku is quite stable. All I do is that I connect to Heroku. I don't connect to the server. I don't know how many servers are there in Heroku. I connect to Heroku through their their interface is like Git interface. So all I do is in command line, I say Git push, and I push my Java code to them. They do all the work they need, they find the right server for my application, they start it, and they charge me for the time my application is kind of active there on their machines. That's a really interesting strategy, again, which is popular and is getting bigger and bigger. So we're stepping away from terminals, from SSH. And the next step, which is the last 3-4 years, I would call it Docker time. It's not exactly Docker, I'm just put the label there. So this is containers time. So we're now starting to think in terms of containers, not servers anymore. The container is kind of, you know what container is probably. The container is a small, it's like like a machine which is able to work somewhere, but there's no physical server behind that. We just know that this is a machine that contains the fully functional operating system inside, like Linux, for example. So we have Linux in this container. Everything is pre-installed there, and then we just get this container, and our application is also there. So we put everything together, the system, the operating system, our application, all together. And then we just get this container and give it to some server or to some platform as a service. It doesn't matter. So we give it to somebody, and then that somebody starts this whole thing, and it starts to work. So I'm jumping back. So in both cases, they're all joining here, I think. Because platforms as a service, they also start to understand containers. Because just giving a Java application to Heroku, it's okay if my Java application is kind of simple. But if I want to put Java plus MongoDB plus, I don't know, some load balancer plus some extra software for Linux, then I can't do that. Because for Heroku, I can only give my Java code, that's all. So I cannot give them Java code plus C++ code and say, run it all together. It's not possible. So all they can do for me, they can run Java application. It's kind of limiting. It's not enough. The same here. The same with the Elastic Beanstalk. So they only understand one language. It's not good. In case of containers, we're all merging here. In case of containers, we package all together, and then we either can drop that container to the server, to the machine, knowing the IP address, or give it to platform as a service and say, run my container. When you start that container and run it, you don't care what's inside the container. C++ code, Java code, whatever, MongoDB, it doesn't matter because it's a fully functional operating system inside the container. If you don't know what this container is, you definitely need to read about it. It's really easy. It's not so difficult, this containerization paradigm. And a number of solutions. So, well, first of all, the DevOps, that term kind of started to become more and more popular in the last few years. I think together with this containerization idea that we kind of stop saying system administrators, we're talking about DevOps. Because developers are now more and more interested in creating the application together with everything around it. So we're not like before, we are writing the application and then system administrator knows how to put this application to production. Now, when we're developers, we know how to put everything together. I know how to write my Java code, and I'm also interested and I want to know how this Java code will work together with everything else inside the container. So that's why DevOps. So we join together developers and operations. Dev is people who write code. Ops are people who actually put pieces together and make sure they work together. So that's why DevOps is, I think, becoming more and more popular because of this containerization strategy. I think so. They're kind of joining. They're kind of going together. Kubernetes and Mesos, kind of popular products, which help you to administer many containers running everywhere. It's like this Chef software. The Chef was for managing servers. Now that guys are helping you to manage containers. So you just give them a container and you configure, and you say, and you explain where are the servers, where to put these containers. And the Kubernetes will just put them everywhere, stop and start them, and you will be able to manage everything from one central point of control. Because again, if you have 1,000 servers and you have 5,000 containers, it's going to be quite difficult to go to each server and start and stop the different containers. So you need some management tool which will help you to administer containers. CloudFormation is not exactly about containers, but it's kind of the next step also in Amazon configuration. So CloudFormation is an Amazon service which helps you to pre-configure your, it's not exactly, they don't deal with containers, but they help you to pre-configure how your application should look, and then without knowing the IP addresses, they just start everything for you all together. So they start a machine, they start the DynamoDB database, they start a private network, they start something else, and they start in one go. So you go to CloudFormation, you click the button, and everything just starts all together. So you don't need to do it manually. It's kind of similar to Chef, but a bit more advanced. And the next talk after mine will be about about CloudFormation as well, so I recommend you to attend to know more about it. I'm not a regular user. I tried it a few times. It helped. But if you're really serious about Amazon, you definitely need to know that one. Docker Hub. Who ever used Docker Hub as a user? 1, 2, 3, 4. Oh, that's great. 15 people. So for people who didn't use it, Docker Hub is it's a free. Well, I never paid them anything, but I guess there's some paid accounts could exist. But I never paid. So all you do is you create in GitHub. You create the configuration of your container in one simple Docker file, so-called. You explain that you need Apache, you need Java, you need MySQL, you need that kind of software. You just write a script, how it should be executed. And then you connect Docker Hub to your GitHub account and say, create an image for me from my configuration. And Docker Hub, what they do is that they get this configuration from your GitHub account, they start a server, some server, they run Docker over there, asking Docker to build that image for you. I mean, to put to make the binary file, the big 4 GB binary file out of all these configurations. They build it for you and they keep it there on their machines. Well, they use, I think, Amazon S3. So they just keep it there, and then everybody can use that image, that Docker image, for their purposes. It's really popular now, and the integration between GitHub and Docker Hub is really tight, really good. So I recommend to take a look at it. So this is the first part of my presentation. And now I think what's going to be the future. This is the past. Not the past, this is the present. So this is what's happening now. It's great. All these tools are good. You need to know them. And they really help. They really turn us, developers, into DevOps. So now clear developers, pure developers who don't know about their software will be deployed are not the real developers. So if you're serious about writing software, you need to know how to containerize them. So you need to know how to your software to make sure that your software is presented as a container to their users. So just making the software and saying, I don't know about how it runs on the server is not enough. It's not professional, I guess. So we need to be more DevOps than just developers. Am I clear so far? So you ready for the future? Okay. Well, I'm not, because It's gonna be more a prediction. So I can't demonstrate you live how it's gonna work. I can't show you how exactly it will happen. I can't demonstrate you any tools because either I don't know them or they don't exist. But I guess they will be created. So my vision is this: is that, well, let's think I am the DevOps. Let's say I'm a good developer and I want to create my application so that it works together with the container. So I want to write Java code and I want to create this Docker file next to my Java code. So, and I want them to work together so that somebody starts that container and makes, you know, HTTP requests, then there will be HTTP responses. How do I do that right now? I write Java code, I write unit tests, I run them together, I make a build more or less clear. The Java code works. And now I create Docker file. I say install Java 8, install this, install that, install all the packages we need together, and my software. Then I run Docker build, right? It's called to create an image, Docker build. So I run Docker build to create an image. Let's say I have some errors there. So the Docker build fails because, you know, some typos or whatever. Okay, I make it clean. I make it work. So I have the Docker file and I have the image. The image is created. So I have the Docker image. And then I run it. And it doesn't work. So what do I do? In most cases, right now, what's happening to me, I do Docker run with the SSH daemon inside the Docker container. So I start that Docker container, and then I log in there through SSH, like 25 years ago. And I see what's wrong there. So I'm trying to make changes. I'm trying to understand why it doesn't work. So I'm kind of debugging it. I'm debugging and I'm making changes. I'm thinking how to do it right. And then I make the changes and rebuild the Docker container, and I try again. And then I try again. It's more or less okay if that's one Docker container. But there are a number of them. If the application is more complex, then this debugging will be quite difficult. And in the end, what we have now is that even if we have Docker containers everywhere, in most cases, people still have SSH access to them. They still access them. They still, you know, they use them directly. They get connected to them, and they make modifications inside containers. So we don't have immutable servers so far. We just have an idea of immutable servers, but still when we start that containers, in most cases we'll log in there and we'll make changes there to make them work. What I think will happen is that we will build an application in the future. The Java, some code, plus the container, and plus the testing level on top of containers. So it's going to be the app, the container, and some sort of integration tests around that container. So when I create the code, I write it and I write tests which will check that my whole application together with containers works together as a whole big app, you know, which is deployable. And then if it doesn't work, then I just try to build it all together and it fails. And then I make changes and I build it again and I run it again. It fails again. I make changes, I run it again. But I don't log in there, I don't do debugging. Like it was like unit testing in programming replaced debugging many years ago. So now if we're actually debugging when writing code, it's kind of a bad practice. So it's better to write unit tests and do test-driven development. So you create a test, and then you create a code, they work together, and that's it. Again, you create a test, you create the code, you put together, and that's it. You don't go into the code, you don't go step by step like debugging. It's like from the past. The same with the servers. So going to the servers through SSH, it's the past. The future is is unit testing them. Well, integration testing them. How exactly it's going to happen, I don't know these tools. I don't think they're still like they already exist, but that's I think will be, and then it's going to be the future. And then when it's the future will come, then the applications will be delivered as completely in GitHub. So everything will stay in GitHub. This is my Java files. These are my Docker files. These are my tests. So you compile, you build, you run the tests. The application works in the test environment, on the test machine. And then you exactly like that, you get all these containers together and deploy to production. And there is sort of a guarantee that it works in production. That's, I think, what's going to happen. So that's why I'm saying keep your servers on GitHub. So your servers will not be somewhere where you know. It's not going to be, you're not going to have like IP addresses of them. You will have some platform where you can just drop all your containers together and the platform will just start them all together and it will work. So you will not care about IP addresses, you will not care about SSH. And if it doesn't work, then you get back, you check your tests and you see why, what did I miss in my tests? That's exactly what you do when you do unit testing in the software. So you don't debug if something doesn't work. You reproduce the problem in the test. When you created the app, you put it in production, then in production it crashes, you get back to your code and try, the first step you do is you try to reproduce the problem in a test. If you don't have enough tests, that's your bug. So you create extra tests to reproduce that failure you just saw. And then you create an extra test, and then you make sure the test fails. That's a success for you. If you manage to create an extra test which fails, then you fix that test, then you build this whole thing again. If it's green, if the build is clear, then you put it to production again. It crashes again, you get back to the code, and again, reproduce, try to create the test again. It fails, great, it's success, and then you fix it and put it back. The same will happen with server configuration. When it crashes in production, you're not going to go there through SSH and fix it there, here and there, because you know how to. You will get back, reproduce in the test, which will catch that bug in your Docker configuration, in your container configuration, and then redeploy the whole thing. So you will never touch production. You will only redeploy the whole thing with all the containers together. And that's why it's called immutable servers. So all your servers will be always starting from scratch. You deploy it, you open the web page, it crashes, then you drop everything, rebuild the whole thing, and put these new containers there, and all servers start from scratch. So you never make modifications to servers. That's what I think is going to happen. And that's, yeah, and of course, it's going to be no SSH. So the SSH, the ability to log into the server, I think is going to be gone. We're not going to do it live. And we will not going to do it locally. It's going to be always Docker file configurations. That's all I wanted to say. Now let me know what you think. Am I close? Am I thinking to the right direction? Yes? Yes? One yes. Do you have no? Yeah. Well, yeah, we were here. So we're not there. We're not in the future. We're in the present. So we use Docker Hub. We use Docker. We use Amazon images, of course. We don't use Chef anymore. So we decided to go for platform as a service completely. So this is the way we decided to took, and it's kind of I'm happy about it. I'm not sure how would that work if we would. We don't have huge web applications. We don't have applications with hundreds of servers. So I don't know exactly how would that work with the Elastic Beanstalk or Heroku if we would have hundreds of machines, but I think they will be able to handle that. But some people say, you know, and we don't have security constraints because some companies, they have really tight security constraints and they say, no Amazon, no Heroku, we just need to have our private data center, and that's why install like 100 machines and then deploy, and then we need to use Chef. But I think it's just the wrong thinking, the wrong way of thinking, because the main reason I always give back is that think about how much effort Amazon spends on security and how much effort you can spend in your private data center. So in case of Amazon, you just trust one company, which is a huge American company, which, I mean, yeah, we are in Europe, they're in America, but still, we just trust one big company. We sign a contract and we give them our data and everything. And they pay millions of dollars every month for security. How much we can afford for our data center. So that way of thinking, saying that Amazon is insecure, I mean, Amazon is another company and we need to our company, is just wrong. So I think this is the right direction, platform as a service. Answering your question, I'm a big fan of Heroku. I'm even an author of the plugin for Elastic Beanstalk, the deployment plugin. I created myself, open source plugin for deploying Java applications to Elastic Beanstalk, because the plugin which existed on the market at that time was not really, you know, convenient for me. It was quite... Huh? No, plugin for Maven. Sorry, I didn't say. For Maven, yeah. So Maven plugin, which allows you to deploy your app to Elastic Beanstalk in just one line of code. So you just say, use my plugin, and then say deploy, and it does everything. Because deploying to Elastic Beanstalk is kind of complicated, you know, set of steps. So it's not that easy. Deploying to Heroku is also not that easy if you want to do it automatically, but it's again like 10 lines of code, which you can see in a few of my open source apps. I also automated that. So I'm a big fan of these two solutions, answering your question. Yeah.
One comment, how does it scale to, like, you're talking about deploying to servers or deploying to cloud. How does it scale to deploying to mobile devices, your TV, your, I don't know, vacuum cleaner, Internet of Things?
Your watch, yeah?
Your watch, wherever.
Well, as far as I understand, the deployment to all of these devices, they're kind of two-step deployments. So you, as a developer, you deploy to some platform, Apple Store or whatever, and then that platform manages the deployment to all these devices all over the world. So there's two-step deployments. The second step is, I don't know how they do it. Honestly, that's a kind of massive problem. They deploy to millions of devices. How we deploy to the platform, it's similar to how we deploy the, for example, I'm developing open source software for Ruby, for example, or JavaScript, NPM. You know what NPM is? It's like a repository for Java libraries. So I develop locally, and then I deploy to NPM in one go. Say again? JavaScript. What did I say? Oh, JavaScript, sorry. Yeah, so the JavaScript libraries I deploy to NPM, and then NPM gives it to millions of users. So all I need to automate is deployment to the NPM. So
it still gets down to like SSH to your device if you're you don't have like Apple-like platform for your device, and then like run npm install or whatever.
Locally, I have to do NPM. Well, you're talking about deploying from NPM to people, to users, to end users?
If you're deploying, if you're a small device maker.
Then you need to use some, if you're the maker of device. In that case, I never saw that problem. I didn't do that. So, but I can imagine that that's.
You have to have like similar abstraction layer. My hardware is described in GitHub. It has these and these dependencies. This software gets inside, and then like the magic you describe happens, and I have my software.
I guess so. Yeah, I think so. I think something like that will happen. I don't know. They don't have containers, right, for the Apple Watch. So there's something else inside. That's just an Apple app. It's just the same iOS, right, in there. So you just package it. Well, in that case, I think every company has its own container idea. So you package it the way, like iOS application. It's kind of a container inside. If you unarchive it and you see what's inside the iOS app, just folders, files that explain how the app is supposed to, how to run. There's some resource files, some code, all together. And then the device knows how to run that container. But it's their own, again, the idea is containerization. That's kind of a common idea for everybody. We just want to deliver software together with environment, which didn't happen before. Before it was small pieces of software, and somebody will be responsible for the environment. Somebody. Now it's more like, it's more like packages going together with everything else. And that's why, and we're going to the and we're making it even more extreme, delivering something which nobody can touch. Because now it's kind of containers which we deploy and we install, and then, but still they're kind of available for, we can get into, we can see what's inside. And that makes it unstable. The whole deployment is really unstable because it's modifiable. We want to make them immutable. So you put it on the server, you put it somewhere, you put it on Apple Watch, and it just boom, used somewhere there. I mean, it just runs there, and we don't touch it. If we don't like it, we just drop it and install it again. We never modify what's being executed there.
You need to be able to look inside to understand what went wrong, what you have to fix if it fails, or when it breaks.
That's what I'm saying. So for that, it's like kind of a debugging idea. So if something goes wrong, of course, we may log in there and and check what's inside. But the better approach is don't allow us to do that. Don't do that. But get back to the development environment where you created that and create a unit test for it. Like if you look at the container, for example, given a primitive example, you created the container with some application inside. You put it on the server, you start it, and it's an empty page, like white page, nothing there. But you're expecting a website. Then you question yourself, how come I build it locally, my test passed, and then I deployed there, and the page is white. So you get back here and you try to create a test which will prove that the bug is there. Like in the unit testing, like in the test-driven development. You create a test which proves that your code is wrong. And then when you manage to do it, when you manage to prove it, then you fix the bug and deploy it again and see, okay, the white page is still there. You get back, you create another test. And then eventually you will create test number 15, which will actually prove that, here is the bug. That's the problem. That's why my container doesn't work there. But then you will have 15 tests, the container, the application. They all together is way more stable solution than something deployed there plus the system administrator who knows how it works. You just remove the human component from there. You create something which is stable by itself. So you create unit tests for containers. Yeah.
I'm not a developer, so maybe it's something which I just don't get. But this concept is strange for me. If the application does not run in production, it's not that you're going to write the unit test because you don't know why it fails. So you need to pinpoint. You need to go into the server. You need to understand what was the exact situation, what was the state of the application in which it failed. So for that you need to go to the server and pinpoint the issue. Then only you can go back to write the unit test.
You need to go to production application.
Yes. You need to go to the logs.
To the logs.
Yeah, of the production. The system to understand what was the state in which it failed. Because you can't go just let me think maybe it failed because of that's all.
I don't have an exact answer for that, but I can only compare that with programming. So in programming, people always kind of often say the same to me. They say, look, if the code doesn't work, the only way to fix it is you need to debug it. You need to go step by step, line by line, tracing your variables and see why it doesn't work. And my answer is that I'm not doing that for the last 10 years, or maybe 5 years. I'm not doing debugging at all. I'm writing a lot of code. All I'm doing is unit testing. So I'm trying to break down the problem into smaller components, into smaller pieces, and create unit tests. And I write many, many, many unit tests, and eventually one of them will fail, will say, boom, I don't pass. And that's the moment I catch the problem. And that's the moment I fix the bug. And they go together, and and the application is fixed. I don't know, I mean, I'm not like really, I don't know how it will happen with servers, exactly how. So I get your point. Of course, sometimes you need to see what's there, what files are missing, or what's going on, and you need to see logs. But that's what I'm saying. I don't know the tools, but I hope they will show up. We will have tools which will allow us to do unit testing locally, easily. Yeah. That's true. The same as in programming. The same as in programming. We have like a number of modules. We create unit tests for them. They pass, and they put modules together, and together they don't work. And that's why we create new levels of testing.
Still want to go and look for the logs because there is no way we will understand that.
What if you want to debug the unit test?
Then you just run them. I mean, you run the test and see the output.
But how does the output come to you if you are not connected to the remote machine?
To the remote machine. You reproduce this whole thing in your unit test, in your integration test. Let's call it integration. Just local, yes, just local, not production, yeah. So the logging, for the logging, I think, yeah, for the logging, we will see the logging from production. We're not going to SSH there. We will see the logging. We'll see what's going on there. That's, I guess, will happen. So we know what's going on there, but we don't touch we don't go to the server. We don't SSH the machine. We don't SSH the container. We just see what's coming from them, from all the containers. Yeah, the logging we will see. Yeah, we have the logging platform. We connect all these containers to the logging platform, and we see what's going, what they say, what these containers say. But then when we want to fix, we don't fix there. We always fix locally, and then package everything and redeploy the whole thing. So that's my point. So we don't fix the production. We fix only the sources in the GitHub. We fix the text in GitHub. Yeah, let's do this.
What Yegor was trying to say and what I was trying to say also is exactly the same. If you get more information out of the failure, whether it is We didn't propose that you should go and try to fix a server as it is live, but if you have a reproducible test case, you get much faster to the reproducible test case if you get more information out of actual failure out in the field. So you still want to have you don't necessarily want to be able to modify your server. So this mutable server concept, I think this makes sense, but you want to get as much visibility into the server as you can in order to diagnose what was the cause, and so you can put in place a test. If you try to develop this, recreate this problem by just trial and error in your development environment, you just spend a lot more time and effort to hit the same problems that you hit in the live environment.
Again, if I make the same, I got it. I got the problem. I got what you're saying, the logic. So you want to see as much as possible in order to fix the problem as soon as possible.
To make a comparison with unit tests and integration tests in coding, when you get a failure report on your code from QA department or from live, you want to know as much as possible information about how the user encounters this problem to get a reproducible. And then you can reproduce the same situation in unit test, verify that indeed now in development your code fails in a way that is consistent with bug import you got either from QA or from the end user, and then you can go and fix your code. If you can get there much faster if you get accurate information about exactly under what condition and how it behaves.
I got it. I got the point. But again, this is the last one. We're running out of time. Yeah. So my answer is that, like in programming, it's kind of counterintuitive, but in programming it's the same. If you allow yourself or programmers who write the code, allow them to do the debugging and to go through the code when something fails, to get if you allow them or yourself to get that information, you are making your life more difficult on the long term because you're not using test-driven development. You're not using tests correctly. So the more information you have about the code that fails, the less interested you are to create the unit test because you know where the problem is. You're just debugging, you're seeing, okay, there's instead of +1, it has to be +2. You just fix it. Instead of +1, you say +2, and the code works, but you didn't create a test. So for me in the future, to understand why it's +1 instead of +2, I don't have the test that covers that problem. So it's always better in programming to hide the source code kind of from the programmer and let the programmer first create tests that reproduce the problem. And if it's difficult to create a test, it's okay. Make more tests, try harder, try to break it down into pieces, but don't fix the code because you know where the bug is. That's the concept of unit testing, of the proper unit testing. So unit tests, you use them as a tool to discover more information about your code. Not the other way around. Not just you discover the information and then, okay, now I write the unit test because I found out the bug. So you have to find the bug only after you have the test, not the other way around. The same, I think, will happen with servers. I don't know technically how, but that's the direction. Thank you very much. We're out of time. Thanks.